Namaste from Dhananjaya Kumar and welcome to each and every one of you for joining this video series dedicated to intelligent children of the world. In fact, all children of the world who are potentially intelligent, brilliant. These videos are also dedicated to wisdom teachers, teachers who can go beyond the fixed knowledge taught in regular classrooms. And I will try to give you many examples that you can use and invent your own examples. So, if you are trying to convey some fundamental concepts of mathematics, arithmetic, numbers. So let me give you just one example. If you tell kids, by then they will know 1 plus 1 equals 2. So you ask them that we are trying to go beyond number 1. So if 1 plus 1 equals 2, then challenge their imagination. Bring them 2 mangoes and say, well, 1 mango plus 1 mango equals 2. So equals 2 mangoes. Then bring another fruit, apple. So put 1 mango plus 1 apple. Then ask them, what is the total? They will be inclined to say 2, but they'll say, well, there is not 2 mangoes or 2 apples. So 1 mango plus 1 apple does not make 2 of anything, mango or apple. Then the children say, okay, which means that the number themselves don't mean anything. What they are counting is what matters. So, for example, an apple and an orange are not 2 apples or 2 oranges, but without specifying whether one is apple or one is orange, you can say what is 1 plus 1 equals 2. Very simple. But 1 orange plus 1 apple is not equal to orange or apple. But you can transform it. Equals to fruits, because fruits is a group of fruits, can be 10, 20, 50, 100 fruits, but each fruit is different. A number allocated to one fruit, that number means that fruit. The second fruit is another fruit. So if you line up all fruits, one each, one of a kind, you will find that numbers are adding up, but these numbers, when you add up, don't mean which fruit. 1 apple plus 1 orange equals 2, not apple or orange, equals 2 fruit. Similarly, if you add a mango, 1 plus 1 plus 1 equals 3 fruit. Then that 3 larger number than 1 loses the context in which number 1 was imagined. I'm not trying to make it complicated, but number 1, you have to explain to kids. Ask them, what is number 1? Number 1 could be 1 planet. Number 1 could be 1 sun. Or number 1 could be 1 atom. Each of those number 1 is not same, and within 1 there are large numbers. So for example, you 1 million, when 1 million is 1, but million is a million ones. Interesting. Or you take 1 apple, okay, ask them, what is this? This is 1 apple, okay. Then you divide the apple into half, 2 pieces. Now what is this? This is 2 half apples and divide them further too. So now this is 4 1/4 apples, and ask them how many pieces you can make out of one apple. Then say, well, they can make maybe 10, 20, 30, 50, 100, 1,000. Then you tell them, no, apples are actually made of same stuff that we are made, atoms. So one apple may have 1,000,000 atoms. Each one of them are one at a time. One planet may have trillions and trillions of atoms. So within one there are large numbers. Individually there are large numbers. Then when next time children see one, they will think what is hidden inside that one. To find out, first you have to know one of what. Then one of what will tell them how many pieces are there and how many times it can be divided. Then you can say that, okay, now you know, in primary school, you know 1, 2, 3, 4, 100, 101, 1,000, etc. They say, okay, if you keep counting for a long time, what is the largest number you will reach? If you keep counting 1, 2, 3, 4, 5, then it opens up their mind. Oh, I can count all my life and still not reach the largest number. If I count it for 100 years, keep counting. Don't eat or sleep or go to school, keep counting. That's a very large number. But can a number be even larger than that? Can you keep counting for 1,000,000 years? If you can live up to 1,000,000 years and you keep counting, would you reach the largest number? Maybe not. So open up kids' mind, what can be the largest number? Older kids may say infinity, infinite number, largest number. Well, infinity is not a number. It can be any number. If infinity is a number, then you can say infinity times 2 is a larger number, or infinity plus 1 is a larger number. So, in other words, children will know that actually there is no such thing as the largest possible number, because you can always add 1. Okay, how about smallest number? How small you can get as a number? Okay, well, smallest number is 1. Well, that's a whole number. A number can be less than 1, like 1/2. So, what is, if you keep going smaller than 1, how far can you go? Well, it can be half, it can be a quarter, it can be 1/10 or 1,000,000th or 1,000,000,000th. There is a long journey to get to the smallest number, smaller than 1. Now, the kids will be forced to think that suppose I reach the largest number, I can divide that into half. So that's even smaller, which means it is difficult to imagine the smallest possible number or the largest possible number. So these are the ways, this is one example of how regular classroom curriculum has a fixed knowledge, fixed answer, and there is nothing beyond that. But you can take the same example, same mathematical or science or any subject, and push their imagination to imagine further, broader and broader. Then they will not be limited to what is taught inside the classroom. they can think, imagine much bigger. And that is the idea. Thank you for listening and watching, and we'll come back with some more examples.